Assalamualaikum and good evening to the lecturers. My name is Muhammad Khairul Ibrahim bin Ahmad Saimi and my matrix number is MA19223. Today, my teammates and I will present the principle of binary theorem as experiment, including theory, methodology, data, and discussions. Next, let me pass to the next presenter.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Tuan Muhammad Zat bin Tuan Muhammad Iman, MA19257. We are from Group 6 in Section 2, and today we are going to present about Experiment 1 Bernoulli's Principle. First, we look at abstract. In this experiment, Bernoulli's Principle is utilized in data analysis. In 1797, the Venturi effect was published by Giovanni Venturi and applied Bernoulli's principle to a fluid that flows through a tube with a constriction in it. The objective of the experiment is to study the efficiency and performance at the different operation conditions. We have stated that sample calculation and the plot graph to make the comparison performance execution bands for the various flow rates using the velocity and pressure data that we have obtained. For Chapter 1, Introduction. 1.1 Background. Bernoulli's principle is the relationship between pressure, velocity, and elevation in a moving fluid, liquid, or gas with compressibility and viscosity, internal friction, and a steady or laminar flow. Bernoulli derived the equation from first principles, which are Newton's law of motion, and the derivation shows why Bernoulli's principle works. Next, 1.2 Problem Statement. The total pressure is measured using the pilot tube on the right side of the instrument. The multitube manometer at the top of the equipment is used to measure the static head. We must examine various assumptions, such as the flow must be consistent and fluid parameters such as speed and density should not fluctuate over time. Next, 1.3 Objectives. The objective of the Bernoulli principle experiment are to discover Bernoulli's principle for a viscous and incompressible fluid flow in an experimental setting. Second, experimental verification of Bernoulli equation for fluid flow in a flow channel of varying cross-sectional area. And last, to determine the dynamic head and static head of the fluid flow through a volumetric tank. And next, for 1.4 Scopes, the scopes of the Bernoulli's principle experiment. First, by using a timer, determine the fluid flow rate via the tube. Second, to look at the overall pressure head, static head, and dynamic head variations. And last, at the top of the equipment, a multi-tube manometer is used to measure the static head.
In theory, W. Bernoulli stated that the fluid system is assumed as the flow is steady, incompressible, and featureless based on the law of conservation mass and energy. This assumption can be defined as this equation, where Q in is equal to Q out and energy in is equal to energy out. Besides that, Bernoulli also stated that with the increase of flow velocity, the pressure of the fluid will be decreased. This is called Bernoulli principle. In contrast with that, the decrease in the flow velocity, the static pressure will be increased. Linear principles can also be expressed as the ideal fluid in the same streamline, which viscosity can be ignored and cannot be compressed, and this question can be expressed as shown. Where for P1 for the section 1 and P2 for the section 2 based on the law of conservation and mass energy. The potential energy, fluid energy, and kinetic energy are the mechanical form of energies. These energies can be converted to each other that Bernoulli's principle state, and when the fluid is in the ideal fluids, which is steady, incompressible, and frictionless, the total energy of three kinds are constants. Therefore, the equation can be simplified by dividing the rho P as the question is shown.
Hello, my name is Putri Nansova binti Kamarisham. So I would like to my matrix number is MA19251 from section 2G. So I would like to talk about methodology. An experiment was investigated to achieve the objective. This experiment is to investigate the change of total pressure head, dynamic head, and static head. So this is the apparatus and the procedure that involved in this experiment. So this ventiometer, this pitot reading, and this manometer. So the manometer, pipe valve and water flow, we want to make sure it fully open and pipe valve half open. So the motor pump will start so that the water can flow in the manometer valve and the pitot. So the manometer valve and pitot were closed. So after that, the pump was stopped and the pipe valve 2 was closed and the pipe valve 1 fully open. So manometer valve and single pitot were opened carefully to allow the atmospheric air to get into it. So both manometer and pitot manometer were closed when about half of the columns were closed. After that, pitot manometer and manometer valve were reopened. So pipe valve 2 was fully open. The water flow control valve was adjusted so that the position of all water levels in the manometer were readable starting from tube 1 until tube 6. All 6 positions of pitot head and static head in the venturi tube were read and recorded. So the data of static head and pitot head were recorded and tabulated. So 5 liters of water were recorded by using a stopwatch. The water flow control valve was adjusted for another 4 flow rates and step 8 until 11 was repeated. That's all for me. Thank you.
Hi, Assalamualaikum and very good day. So my name is Muhammad Farhan Hakim bin Razab and my metric number is MA19244. So today I'm gonna present about our results of the experiment. So as we can see here, this is the data that I got after I calculate. Okay, so for the first point, I got the measurement of volumes. So basically 0.442945 and then 0.315956 and the pressure is 98.1. And then for the second point is 0.542494 and then 0.503778 and 147.15 for the pressure. And the third one is 1.252837 and then 1.298701 and then 784.8. For the fourth point, 0.828674 and then 0.862069 and then 343.35. And for fifth point, 0.442945 and then 0.434783 and then 98.1 Pascal. And then for the last point, I got 0.0981 and then 0.315956 and then 49.05 Pascal. Okay, for the separate equations, for the Q, we need to find a Q by using this kind of formula. So we take a volume, divide it by thousands, and then after that, we need to divide it again by time. So as an example, like 5 liter divided by thousands, and then divide it again by the 25 seconds of the time, and then we got the answer 0.002 meter cube per second. And then we need to find the difference of height, which is we take the height pitot minus by height stat, which is 180 divided by 190, which is we got 10 millimeter. And for the volumes, we need to use this formula to find it, which is a square root 2g bracket height divided by thousands, and then we insert the value square root 2g bracket 10 divided by 1000, and then we got the final answer 0.442945 meter per second. And then we calculate the volume by using Q, which is we found here before, and then divided by the cross-sectional area, and then we got the final answer 0.315956 meter per second. And then lastly, we need to find the pressure by using this formula rho GH. Okay, so we insert a value of rho 1000 and the G 9.81 times by 10 divided by 1000, which is we got final answer is 98.1 Pascal. So I think that's all from me. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rajina Laili binti Muhammad Yusof. My metric number is MA18045. So for discussion, we had plot a few graphs to make the comparison clearer to the further discussion about the result. So as you can see, this is the graph of static head versus venturimeter position. So from this graph, we can see that at the point 3 here has the smallest cross sectional area, and our graph shows the correct trend as stated in the theory. So we can conclude that the higher flow rate, the higher static head will be. So next is the graph of dynamic head versus venturi meter position in the dynamic head in the system is correlated to the velocity of the flowing fluid. So the trend of this parameter should be contradicted compared to the graph of static head above. So by observing the graph, we can deduce that the result obeys to the theory stated, except for point 4 in the flow rate 1, which is 0.0002. This is caused by the human error where the pitted tube might be placed at wrong position. So the graph is out of trend. The overlapping of reading from this graph might be caused by the insignificant difference between the flow rate.
Hello, my name is Natasha Ko and my matrix ID is MA18029. I am from group 6 and from section 01. I will be presenting about the discussions on the latter parts. Okay, so based on the discussions in figure 9, the total head versus venturi meter positions. So as we can see from this graph, the higher the flow rate, the greater the total head of the system, and which is the total head is the sum of the static head and dynamic head, which is, as we can see from the point 4 in flow rate 1, the Q1 stated here is 0.0002, in which the value does not follow the trend because there is a human error when taking the value of the dynamic head. As for the graph in the measured velocity versus venturi meter positions, as we can see in figure 10, when the cross-sectional area of a pipe decreases, the velocity of the flowing fluid will increase while the pressure decreases, which obeys the continuity equation in figure 10. So this trend is obeyed by all except point 4, as we can see from here, for flow rate 1 in Q1, in which the value is 0.0002. So the value here does not follow the trend because there is an existing human error when taking the value of the dynamic head. So that is all from me. Thank you.
From the experiment, we can conclude that the experiment was successful. Figuring out the value of the experiment is ideal for probing Bernoulli principle, since the theoretical value and the practical value have minor difference. This problem can be solved if the device were working correctly by the reference experimenters. However, slightly variance may be occurred due to human error. That's it for now. Thanks for watching.